Well, let's jump in and get started with this essentially final topic for the year. Crazy to think that when we finish with our lesson on Thursday, that really is everything taught. So it's just revision from there until the final exams. Okay, so the fundamental counting principle. When we deal with questions regarding the fundamental counting principle, we are dealing primarily with the number of ways, I'll put it in here for you, the number of ways in which something can happen. Okay, so it deals with the number of ways in which something can happen. And what we need to be careful of is that when things can be repeated or if they cannot be repeated. Okay, so when it comes to things like letters or digits, numbers, they can be repeated. They can also not be repeated, but these are things that can be repeated. If we're talking about something that cannot be repeated, like people. Okay, so we just need to be careful of what happens, the changes that happen when things can be repeated, cannot be repeated, and we'll talk a little bit more about those this evening. All right, so let's just jump into the first example. It says to us there is a meal that can be made up in the following way. So you can choose between meat, fish, or chicken, and your second choice is mashed chips, baked potato, rice, or vegetables. How many different meals can be made using these choices? So instead of us having to go meat and mash and meat and chips and meat and baked potato and meat and rice and meat and vegetables and then fish and mash and fish and chips, etc., there's a much quicker way. All right, so there are 3 ways in which the first choice can be made, multiplied by 5 ways in which the second choice can be made. So if we multiply the number of ways together, it tells us that there are 15 different meals that can be created using these options. All right. The second example that we're going to have a look at, and again, it's really just a very similar example to the first one. There's just more going on here. All right. So a gift pack can be made up in one of the following ways. So choice number 1 was to choose a CD out of 4 possible CDs. So there would be 4 options for choice 1. Yes, Mamelo. I see your hands up. Do you want to ask a question?
You'll have to unmute on your side, Mamelo. Oh, it was a mistake.
Oh, it
Okay.
was a mistake. Oh, okay. All right. So there are 4 ways in which choice number 1 can happen. There are 5 different types of chips for choice number 2. For choice 3, you can choose 1 chocolate out of 12 different types of chocolates. And then for choice 4, you can choose 1 type of fruit out of a possible 3. Okay, so again, what we would do is we would multiply our various options together. So 4 by 5 by 12 by 3 means that there would be 720 different gift packs. That could be created. All right, so the first activity is really quite simple. All right, a party pack of 3 items can be made up by selecting 1 item of each of the following choices. Okay, so how many different party packs can be made? If choice number 1 is Smarties, Astros, Jelly Tots, Wine Gums. Choice number 2 is Coke, Fanta, Sprite, Ginger Beer Cream Soda. And choice number 3 is Donut, Chelsea Bun, or a cheese roll. So as far as choice number 1 is concerned, how many different options do we have for choice number 1? We have 4 precisely. Okay, 4 options for choice number 1. For choice number 2, how many options do we have? We have 5 different options. Good. And for choice number 3, we've got 3 different options. Okay, so we would just multiply them together, and that means that there are 60 different party packs that could potentially be made from these choices. Daka, you getting 80? Have I done something wrong? 1, 2, 3, 4 by 1, 2, 3, 4, 5 by 1, 2, 3. So why am I getting 60? Should be 60, 20 times 3. There we go. Okay. All right. Now I
That
thought
is 60.
I'd
Sorry.
made I'd made a mistake. Okay. Now things start to get a little bit more interesting. They want us to consider the word Parktown. Okay. Notice that none of the letters are the same. They're all different letters. Okay, so none of these letters are repeated. You are required to form different 8-letter word arrangements using the letters of the word Parktown. An example of such a word arrangement could be the word whatever, which is not a real word. They've just rearranged the letters. This arrangement of letters need not make any sense. How many possible word arrangements can be made if the letters may be repeated? So a good way for you to think about a question like this is to consider filling blocks. So there are 8 blocks that we can fill. So let's just get our 8 blocks on the screen. Oh, we're going to have to scooch over a little bit. We're filling 1, 2, 3, 4, 5, 6, 7, 8 blocks. Okay, and Hlandla says 8 to the power of 8. Absolutely. Now, where does he get this answer from? Well, because we can repeat the letters, it means we have a choice of 8 letters in the first block. Because we're allowed to repeat our letters, we've got 8 in the second, 8 in the third, 8 in the fourth, the fifth, the sixth, the seventh, the eighth. And that's why if they may be repeated, let's just go back. That was part A. It would be 8 to the power of 8, which is some huge, big, enormous number. Okay. 16777216. Okay, so 16,777,216. That's it. Well done. All right. So because we were allowed to repeat things here, what we did is we used exponential notation. All right. In part B, they've told us the letters may not be repeated. So let's just go back and go and have a look. Okay, so the letters may not be repeated in part B. So what's going to happen here? Again, we want to try and fill our blocks. Let's just make that a little bit smaller so we can rub that out without getting rid of our blocks. Okay, there we go. And now you guys are doing exactly what I expected you to do. Okay, so Lesejo says, when do we use 8 factorial? And Awami says 8 factorial, and Cheslin says 8 factorial, and Yolanda says 8 factorial. Okay, so to answer your question, Lesejo, this is when we use factorial. Okay, because things are not able to be repeated. So what that means is that we have 8 options for the first letter. When a letter is chosen out of the word, it means there are 7 letters left. So that means that there are 7 options or 7 ways to fill that second block. If 2 letters are gone and we cannot repeat them, there are 6 options for the third, 5 for the fourth, 4 for the fifth, 3 for that one, 2 and 1. And that is factorial notation. Okay, so factorial notation is used when we are multiplying positive integers by one by the other, and each time we decrease by 1. Okay, so this is 8 factorial. Okay, and it means 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And as you guys have said, the answer would be 40,320. Okay, so far less ways or arrangements of words that we could make if we are not allowing repetition to take place. Okay. Now, Nhlanhla says, what if we could move park, but town remains the same? Okay, lovely question, all right? So, in other words, so here, so are you saying in Nhlanhla you want a T here, an O there, a W there, and an N there? Is that what you're saying? And then the first 4 letters could be muddled up. Okay. Are we allowing repetition with the first 4 letters or not? Does it have to be P and then A and then, or either a P or an A or a R or a K? So which is it in Nhlanhla? No repetition. Then it's exactly what Cheslin would have said. Okay, so 4 by, 3 by, 2 by, 1 by, 1 by 1 by 1 by 1. Okay, so in that case, there would only be 24 different arrangements that you could make. Okay, nice question. Thanks, Nhlanhla. And thank you, Cheslin, for answering that so quickly and correctly for us. Okay, so just an opportunity for you to practice this one. Maybe you guys want to do this on your own. It's not a particularly difficult one. Considering the word Florida, you're required to form 7 different word letter arrangements using the letters of the word Florida. How many possible word arrangements can be made if A, the letters may be repeated? What would we do? The letters can be repeated. And second one, the letters may not be repeated. All right, so you guys answer those on your own, and then you can share your answers with Yolanda and I. Good, Lesejo. That's it, Yolanda. Okay, and for part B, that's right, Mbalenhle. There we go. Good, William. Perfect. Nice.
Sorry,
Good,
Teacher Lee,
Lulu.
in these questions, do they only mark the correct answer, or you have to actually show how did you arrive to the answer? Like how
Well,
Yolanda has it.
no, so they would just mark the answer.
Oh,
So, but I mean, we're going to go 7 to the power of 7 and write what it equals, and we're going to go 7 factorial and we're going to write what it equals. But yeah, it would just be the answer only for an easy thing like this.
okay.
Yeah. Okay. All right. So that's nice and straightforward. 543, and then that was 5040, just like that. Okay, now let's get into something that's a little bit more interesting. Okay, so first question that I want to do with you is a password, all right? And it's made up using the format. Let's just don't know why I always put everything on top of one another. Very good at this, am I? Should be, considering how long I've been doing it. But anyway, okay, so a password is to be made up using the format XXXYY, where X represents any digit from 0 to 9, and Y represents any letter of the alphabet. How many different passwords can be formed in each of the following cases? And then they change things each time. All right, so let's have a look at case number 1A. The digits may be repeated as well as the letters of the alphabet. Okay, so remember, the X's represent the digits and the Y's represent the numbers. So how many digits may be, how many different passwords can be formed if the digits can be repeated and the letters can be repeated? How would we calculate that? There are 10 digits, good. Well done, Nhlanhla. There are 10 digits available. How many letters? 26 letters in the alphabet, absolutely. So, all right, but it's more than that, Lesejo, because remember, we want X, 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 Y, Y. So we want digit, 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 letter, letter. So how many boxes have we got? We've got 5 boxes. Okay, so our letters are going, sorry, our digits are going where the X's are, and our letters are going where the Y's are. Okay, careful, Ayanda. Okay. That's a Cheslin. That's correct. So what Cheslin has written there is 100% correct. Where he gets the answer from is as follows. Okay, so he is saying this. I have 10 options or 10 ways I can fill the first box with a 0, a 1, a 2, a 3, a 4, a 5, a 6, a 7, an 8, or a 9. Because these digits can be repeated, I have 10 ways I can fill the second box and 10 ways I can fill the third box. Now I'm moving on to the letters. I've got 26 letters in the alphabet. I'm using all 26 and they can be repeated in the second block containing a letter. Okay, so that's where we end up with 10 to the power of 3. Now 10 to the power of 3 is not 30, it's 1,000. Okay, because it's 10 times 10 times 10 times 26 squared. Okay, so it's going to be 26 squared times 10 cubed. All right, so that should be 6, 7, 6, 1, 2, 3. Cheslin, I think you said 26 cubed. Sorry, yeah. Okay, so it's not 26 cubed, sorry. It's 26 squared. All right, because there isn't a third box with a letter in it. Okay, so Nhlanhla, what you had said to me was perfectly correct. Okay, no problem. Okay. Amahle, we are doing the fundamental counting principle. Okay, so Rati, maybe Yolanda, can you just find out what Rati didn't understand, and
Yes.
just help them with that? Is that okay?
Yes.
Thank you so much. Okay, let's have a look at the second question. Now they tell us that it's not phrased very well. I'm sorry, Matrix. The digits may not be repeated, including the letters of the alphabet. So you can't repeat digits, and so number digits, and you can't repeat letters. Okay, so this is the answer for A. Let's put an answer for B over there. And again, let's clear out our boxes, and then we can fill them up. Okay, so in how many different ways can we fill the first box? In how many ways can I fill the first box? 10. Good, Lesejo. In how many ways can I fill the second box if repetition is not allowed? Good. 9 ways. In how many ways can I fill the third box if repetition is not allowed? 8 ways. Good. In how many ways can I fill the fourth box, which is the first letter of the alphabet, or it's the first place where the alphabet pitches up, would be 26. And if I cannot repeat, in how many ways can I fill the last box? That's it. Well done. Okay, so this is 10 times 9 times 8 times 26 times 25. Good, and I think some of you did, in fact, put that into the chat. Let's work out what that would be. 468,000. Are you guys getting that as well? 468,000 different combinations that can be made. Good, well done, fantastic. Let's go and have a look at the third one. The digits and letters may be repeated, but the number 0 and the vowels must be excluded. So again, let's go and rub this out. And go back to the drawing board. Okay, so if we are excluding the number 0, how many options do we have, or how many ways of filling the first box do we have? 9. Good. Remember, numbers may be repeated, so how many ways do we have of filling the second box? Also 9. Good. And the third box? Also 9. Okay. Now we're excluding the vowels. So how many vowels are there? That's it, Yolanda. Good. There are 5 vowels, 26 letters, 5 vowels. That means there are 21 ways in which we can fill the next block. But it tells us that we can repeat the letters and the digits. So in how many ways can we fill the last block as well? Sorry, Yolanda, it's not 20 at the end. It's going to be 21. Okay, because we are allowed to repeat. If we weren't allowed to repeat, then we couldn't do this. Okay, so this would be 9 cubed times 21 squared. Okay, which gives us 321,489. Okay, yes, good. Well done, everybody. Perfect. There we go. Thanks for those answers. Let's have a look at question D. The digits and letters may not be repeated, and the number O and the vowels must be excluded. All right, so let's clear our boxes again. And now it's essentially the same question, but repetition is not allowed. Okay, so in the first box, we have what goes in the first box? How many ways? Good, Mamelo. We can fill the first box in 9 different ways. Okay, Nonjabulo's already got an answer there for us. Okay, Nonjabulo, we're a little bit behind you, but we're trying to catch up. How many ways can we fill the next box? How many ways can we fill the second box? Good, 8 ways. And the third box? 7 ways. Good, because repetition is not allowed. Now we would fill the fourth box in. That's it, Awami. 21 ways. And because repetition is not allowed, there would be 20 ways in which we could fill that last box. So we've got 9 by 8 by 7. 9 by 8 by 7 by 21 by 20. What does that give us? 211,680. Okay, good job, everybody. Okay, let's move on to the last question. Now they make it even more interesting. The digits may be repeated, but must be prime numbers. And the letters may be repeated, excluding the first 5 letters and the last 5 letters. Exactly. So Nhlanhla has given us the prime numbers that we're allowed to use. 2, 3, 5, and 7 are the only prime numbers between 0 and 9. Good, Nhlanhla. Perfect. All right. When it comes to letters, we're excluding the first 5 and the last 5. So how many letters do we have to choose from? 2 is a prime number indeed. Lesego is the only even prime number. Okay, because it can only be divided by 2 and by 1. Okay, yes, well done, 16. Okay, so now we've got 4 ways of filling the first block, because we can repeat 4 ways of filling the second, 4 ways of filling the third by 16 by 16. Okay, so in other words, 4 cubed times 16 squared. Number of ways, and as you guys are saying, it would be 16,384 ways in which that could happen. Does that make sense to everybody? Are there any questions about E? I think the others are all right. No questions? Are we all good? Thumbs up, thumbs down? Okay. That's it, Nonjapula. I got the same answer. Okay. All right. Thank you, Gadi, Boichepo, Mamelo, Nhlanhla, Awami. Okay. Blessings, happy. Okay. Amahle, good idea. Okay. I don't know if you've done this section at school. We're just talking about the number of ways in which things can happen. We're talking about factorial notation and exponential notation. Okay. So let's get into something that becomes a little bit more interesting. Sorry, I just want to move this down. Okay, so we know factorial notation. The product 6 by 5 by 4 by 3 by 2 by 1 can be written as 6 factorial. So we've got 6 factorial, 9 factorial, also 0 factorial is equal to 1. That's a definition, but nobody will ever. I'd be very surprised if you actually end up having to work with that. Okay, so I think we've spoken about this, all right, in how many different ways we can rearrange the words or the letters of the word Parktown to form as many different possible word arrangements. Okay, so this is where we start using factorial notation because the letters may not be repeated. So we've all agreed there would be 8 factorial ways in which that could happen. Example number 6 is very much the same. Now they're talking about people. So in how many different ways can 6 different people be seated in the first 6 seats in a movie theater? So now again, people cannot be repeated. Letters can be repeated, numbers can be repeated, but people are unique. Okay, so there would be 6 factorial, which is 720 different ways in which people could be arranged. Now things start to get a little bit more interesting. All right, and example number 7 is what I want to talk about. Okay, so in example 7, it says, in how many ways can 7 vacant places? Okay, Stokozile, which I think did you want a screenshot of this? Sorry, Stokozile was just asking for a screenshot. Is that correct? Okay. So in example 7, it says, in how many different ways can 7 vacant places be filled by 10 different people? So this is different to example 6 because there were 6 seats and 6 different people. So that's why it was 6 factorial. But now we have 7 places that need to be filled by 10 different people. So what do we do now? Can anybody tell me? How does this change what we're doing? I'm going to start drawing the blocks. One, two, three, 4, 5, 6. So there are 7 blocks that can be filled. The people can be moved around, absolutely. So, William, you've got onto something, but you've used the wrong operation. Okay, so let's do it the long way first of all. Okay, in how many ways can we fill the first block? No, Leanne. Yes, and Tlantla, that's right. We can fill the first block in 10 different ways. Okay, how many ways can we fill the second block? There you go, Cheslin. 9. Okay, and the next block could be filled in 8 ways. Then by 7, then by 6, then by 5, then by 4. Okay, because there are only 7 places. What that means is that there are going to be some people standing. Okay, because there are not enough places for everybody to be filled. Now, another way that we can write this is as follows. Okay, we could work out the answer to that, but just setting this out in a different way. If I wanted to say 10 factorial, that means I've got 10 by 9 by 8 by 7 by 6 by 5 by 4 by 3 by 2 by 1. But I don't want the by 3 by 2 by 1. So what I can do is I can divide, because remember, when I divide, something at the top is going to cancel with something at the bottom, and it's going to cancel out. So at the bottom, if I just wanted to stop over here, I can divide by 3 times 2 times 1 at the bottom, which is 3 factorial. Okay, and that's another way in which I can set this particular question out. All right, because the 1s will cancel, the 2s will cancel, and the 3s will cancel. Okay, so 10 times 9 times 8 times 7 times 6 times 5 times 4 can also be written as 10 factorial divided by 3 factorial. Now, how do I know that I have to have a 3 at the bottom? I can get it by saying 10 minus 7. Okay, so this is 10 factorial over 10 minus 7 factorial. Does that make sense? Okay, it just makes it quicker for you to calculate it on your calculator. All right, so you've got 10 factorial divided by 3 factorial. Okay, which gives us 604,800. Okay, so William is saying yes. Cheslin, I can see, gets it. How's everybody else feeling? Is this making sense? And Flintla's happy? Okay, so that's 3 people. Daka's happy, Mamelo, Blessing, Ibuchang, Iwami. Okay. Because 10 by 9 by 8 by 7 by 6 by 5 by 4 by 3 by 2 by 1, Amatle, is 10 factorial. But I don't want the times 3 times 2 times 1. Okay, so I have to get rid of that by dividing. Okay. All right, so now we've got some questions that we can answer. All right, so you guys do these quietly by yourselves. That would be 1, 2, and 3. We'll mark that and then we'll try something else. Okay, so you guys try questions 1A, B, 2, and 3. We'll mark it and we'll move on. Okay, so a couple of things coming through. Okay, Cheslin. Let me just work it out, Cheslin. No, no. So 360 is not correct for 1B. Good, Leanne. Your answer is correct for, not for A. No, sorry. For A, it is correct. I beg your pardon, Leanne. And for B, yes. Oh, no, hang on. Oh, it's 5. Sorry. Cheslin, just give me 1 second. Sorry. Yeah, no, it's not 360. That's it. Okay, so Awami, what you've sent me is correct. Ratty. Yes, William. Leanne. Good. Okay, cool. Good. And Nhlanhla. Good, Leanne. Cool. Okay, try question number 2 now. Yes, Nonjabulo. Yes, Ratty. Okay, so all the answers I'm seeing for question number 2 are correct. Good. Well done. Yes, Leanne. Nice. Good job. Kumo. Lovely. Nice. And then let's have a look at question 3, everybody. Yes, William and Nhlanhla and Awami and Leanne. Good. Okay, Leanne, you really like that factorial notation. Okay, nice. Good job. Yes, Tokozile. Nonjabulo, good. Using it at every opportunity, hey, Leanne. The one year I had a matric student write a little thank you note for the year, and he said something like, thank you for thank you for helping me this year. And then he had like over there, and then he was like, this is double factorial. Which I thought was really cute. So you can use that in your thank you letters to your teachers, Leanne, since you
Wow,
like the
that's
factorial.
cute. So sweet.
And then and then the boys I was teaching this year, they made me laugh because when we done one of these questions and it ended up being 8 factorial, the one boy was like, what on earth is English doing in maths? Like, didn't they, couldn't they stop at X and A? They had to bring in an exclamation mark, and the rest of the class were like, the answer is 8, like emphasis rather than. So yeah, we had a good laugh about that as well.
Oh, it's so cute.
Yeah. Yeah. Okay, so just quickly running through the answers, there were just a couple of people that wanted some clarity. All right, so in 1A, 8 places filled by 8 people, that would be 8 factorial, and we can write down what we would get. In part B, we've got 5 places filled by 15 different people. So that would be 15 by 14 by 13 by 12 by 11. Or, as Leanne likes to do it, it would be 15 factorial over 10 factorial. Just makes it a bit easier and quicker for you to work out what the answer is. Okay, then in number 2, whoever was confused with that, we've got 10 contestants, and in how many ways can we award first, second, and third place? So that would be 10 by 9 by 8. Or if you like factorial notation, 10 factorial over 7 factorial. And then the last one, we've got 4 teachers out of a potential 20. How can this be done? It would be 20 by 19 by 18 by 17, or 20 factorial over 16 factorial ways. And of course, we can work out what these values are. 8 factorial is 40,320. 15 factorial divided by 10 factorial is 360, which a bunch of you had said. 10 factorial divided by 7 factorial. Yeah, I also like this. Somebody said I really enjoy this section. Was it you, Mamelo? Yeah, me too. It's something different, isn't it? It's nice. I also like it. It's quite interesting. If you do statistics and probability at university, they go obviously into this topic in a huge way, and it becomes very, very complex and quite difficult. But yeah, what we do in matric is really just lovely. Okay, so is everybody happy with that? Yeah, fair enough. I think everyone will agree with you on those 2 topics, Cheslin. They're not people's favorites by any stretch of the imagination. Okay, all right, good. I'm glad everybody is okay. So let's have a look at, again, they love these different sort of word arrangements that can be made. Okay, so what we're going to do is let's focus on question number 5. I'm just going to make this a little bit bigger. And hopefully we'll be able to do something a little bit interesting before the lesson ends. Okay, so let's consider the word wiskunde, which we all know is maths in Afrikaans. Okay. How many 8-letter word arrangements can be made if the letters may be repeated? What would we say? There are 1, 2, 3, 4, 5, 6, 7, 8 letters in this word. Good. And Nhlanhla. So there would be 8 factorial ways in which this word can be arranged. So that's 4320. Oh, hang on a second. Hang on a second. It's not. It's so easy to fall into the trap. If the letters may be repeated, the letters can be repeated. There we go. Kumo. Almost getting foxed by my own questions here. Okay. Yes. 8 to the power of 8. Yes. That's right. We've seen this before, haven't we, Kumo? It's 16777. 216. If they can't be repeated, that's when we would say 8 factorial. So this is 40320. How many 6-letter word arrangements can be made if the letters may be repeated? How many 6-letter word arrangements could we make if the letters could be repeated? What would we do here, do you think? Okay, so Lindelwa says that. If you can just tell us where you get your answer from. Okay, good, guys. So a lot of you are saying 8 to, well, some of you are saying 8 to the power of 6. Some of you are saying 6 to the power of 6. Okay, so remember, we have 8 options. Okay, we've got a 6-letter word, so we've got 6 blocks that we can fill. Okay, but we could put 8 letters in here, or 8 letters in there, or 8 letters there, or 8 letters there, or 8 letters there, or 8 letters there. So it has to be 8 to the power of 6. So there's our exponential notation coming through. 8 to the power of 6. What is 8 to the power of 6? There we go. That was correct. So Lindelwa, what you said, perfect. So 262144. Awesome. Now in question D, they say to us, how many 6-letter word arrangements can be made if the letters may not be repeated? So how would we do this? What do you guys think? How many? All right, Nhlanhla. We're going to see now if we agree with you. Nhlanhla, you can start looking at question number 6 if you want to. There we go, Mamelo. Kumo saying the same thing. Good. Okay, so 8 ways we can fill the first block. 7, 6, 5, 4. 3 ways we can fill the last one. Or we can say 8 factorial over 2 factorial. Okay, so that gives us 20,160 ways. 20,160 ways that we could make a 6-letter word arrangement if the letters could not be repeated. Okay, so this is going to be the last thing. I don't know if we're going to get to the last one, but let's just start talking about it anyway. All right, so we have got, oh, sorry. Let's just see what's saying in the chat. Okay, why do we say 2 factorial? Because we don't want times 2 times 1. Okay, so that's why I'm dividing by 2 factorial. Okay, because the 8 factorial in the numerator would include times 2 times 1 at the end. Okay. All right, let's have a look at 6a. We've got the digits 0, 1, 2, 3, 4, 5, 6, 7, and 8. And we're using them to make 4-digit codes. Okay. So let's get our blocks. 1, 2, 3, 4. Okay. So how many different codes are possible if the digits may be repeated? That's it. 9 to the power of 4. Okay, so 9 ways that we can fill each block. All right. Stokozile, that's fine. So 6561. I'll just go up quickly. Stokozile, there you go. You want to take Viskinder, take a screenshot quickly. Okay, let's go down again. Okay, how many different codes are possible if the digits may not be repeated? How many codes? How many ways could we fill the first block? N? That's it, Mamelo, quite right. So 9 by 8 by 7 by 6. Good, I'm getting the same answer. 3024 different ways. Okay, now. Yes, Cheslin, another way of doing it. 9 factorial divided by 5 factorial. Good. So we can also say 9 factorial divided by 5 factorial. Good. Let's just say or. Now, question C. How many codes are numbers greater than or equal to 4,000 and are exactly divisible by 2? The digits may be repeated. So if the number has to be greater than or equal to 4,000, in how many ways can you fill the first block? How many ways could you fill the first block? So if the number has to be greater than or equal to 4,000, how many ways can you fill the first block? You can put a, okay, Bohlale says 6. So you can put a 4 or a 5 or a 6 or a 7 or an 8. So there are 5 ways that you can fill the first block. Okay, because the numbers that can go there, it can be a 4 or a 5 or a 6 or a 7 or an 8. Okay. Then we want a number that is divisible by 2. So if we want a number that's divisible by 2, what sort of number has to go in the end block over here? It has to be an even number. So how many even numbers do we have? We've got 0, we've got 2, we've got 4, we've got 6, and we've got 8. So we've got
Oh, sorry.
1, 2, 3, 4, 5 ways. Sorry, I'm just doing this and then we can do it. Okay. Now they've said the digits may be repeated. Okay, so if digits can be repeated, it means that any one of the 0, 1, 2, 3, 4, 5, 6, 7, or 9, or 8 can be over here. So that would be 9. And then again, because repetition's allowed, we could have that. Does that make sense to everybody? So it would be 5 by 9 by 9 by 5. So 5 squared times 9 squared. And now you can run your poll. And we'll just see if there's any questions. Just do the poll first. And if you've got a question, why is it 5 at the end? Okay, because Kumo, it has to be an even number because the number has to be divisible by 2. So there can only be a 0 or a 2 or a 4 or a 6 or an 8 at the end. Okay, so that's 5 possible digits. that you can have at the end. Any other questions? Okay, Nhlanhla. But it has to be greater than or equal to 4,000. So there can be a 4, a 5, a 4, a 5, a 6, a 7, or an 8. So that's only 5 possible options in the first block, because the number has to be greater than or equal to 4,000. So you can only have a 4, a 5, a 6, a 7, or an 8 in that first block. So that's 5 options.